Welcome to Arrival's R&D lab in Banbury in the UK. I'm Avinash, I'm the President and Chief Strategy Officer for the company. And what we're doing here is we're focused on commercial vehicle segment and producing best-in-class vehicles that have a similar price to fossil fueled ones and a lower total cost of ownership. We're focused on the commercial vehicle segment. That's a typically underserved segment that has really taken the same approach for the last 50 to 100 years. That is the typical approach of the industry, which is to manufacture in very large factories and ship those vehicles around the world. Now, the issue with that is, one is the price. As we're going electric, we're removing the fossil fuel powertrain and replacing it with an electric powertrain, and that's having a price premium to turning electric. The second is there's no flexibility in the design. And what you find in talking to commercial vehicle operators, that the way they use the vehicles actually changes depending on the local environment they're in. And at Arrival, we've managed to solve both of those problems. So we have an electric vehicle that is a similar and competitive price point to fossil fueled ones, but we're also able to manufacture them locally through these microfactories. So that means we're able to customize the vehicles and produce them at basically any volume and still maintain profitability, but at the same time provide our customers with the best-in-class product that's fit for purpose for their needs. Today we'll take you through how we do that. We'll show you the products, we'll show you our components, how we get the cost down and how we increase the innovation in the vehicle, and we'll show you our robotic cell, which is one of the enablers for the microfactory, and you'll also get a first look at our composite plant. One of the ways we drive our costs down is through the use of these pioneering microfactories. So all of the technologies are designed upfront to be assembled using a low footprint, low capex microfactory. What's important about these microfactories is they can be deployed anywhere. You don't need any special buildings, you can use existing warehouses, and you can convert them to production plants very quickly. So this is actually a fundamental change to the way the industry is currently working, which are these large central factories. Ours is a distributed model, but what's key here is that everything is designed upfront to be assembled using these. And what's important is all of that passes through a software loop to validate that the microfactories can build any of our products. We have hundreds of people working in our robotics department creating these flexible robotic cells. And these cells form the backbone of the microfactory. In a typical plant, you have an assembly line, and if there's any change to the vehicle, you actually have to change the line, which is significant capex and time. In an Arrival microfactory, using these flexible cells, we're simply able to reprogram the order that the vehicle goes to each cell and the operations of the cell itself, and we can actually produce different variants. The benefits of this approach is immense. A typical factory will use thousands of robots to do production. At an Arrival microfactory, we use 70. Robotics have been used in the auto industry for a long time, but what's different about Arrival's approach is the flexibility that we have. So instead of pre-programming all the robots to operate in a certain way, we're able to configure and use computer vision to actually produce freedom in the cell. So for example, what I've just done is placed the part randomly on an autonomous mobile robot. And this is actually pretty significant. Instead of having to be precise in terms of where all the layouts of the parts will be for the robots to understand their process, I'm able to basically put it anywhere. And we use computer vision for the robots to track and perform the task. To enable the cost saving and the ability to produce our vehicles using microfactories, we have designed all of the components in-house. We're vertically integrated. So it's the hardware, the software, the robotics, it's all done within Arrival. And what you're seeing here is the type of components that we're building. So all of the high voltage and low voltage systems we design in-house. So that includes our modular battery, our BMS, traction inverter, DC-DC converter, human-machine interface. These are all actually done within Arrival. Designing these in-house also enables us to upgrade the vehicle over time. So for example, with our HMI system, the human-machine interface, if there's ever new technologies that come out, we're actually able to replace this component with the later version. That means all of our vehicles are also autonomous ready. Right now, the autonomous hardware cycle is on a 12 to 18-month refresh cycle, and the existing vehicle architectures can't deal with that. With Arrival, we're able to swap in and swap out those technologies as they become more mature. This approach prolongs the life of the vehicle and also saves the commercial vehicle operators cost in the fact that they can reuse the same asset and upgrade it over time. We're here in Arrival's composite factory, and what you're about to see here is one of the ways that we reduce the cost of an electric vehicle to help become competitive with fossil-fueled ones. So to do that, we had to be vertically integrated, and we've looked at everything. So we've really questioned everything from the ground up. And what you're going to see here is what we're doing in terms of how we look at the materials that are used to make panels, which in the typical industry has been steel, and that's forced the requirement to have really large metal stamping plants and paint shops to be able to get to the fit and finishes of traditional vehicles. But what we're doing is something totally different and unique to the industry. So in terms of the production process, it comes off the roller, we laser cut it, and then through a series of robotic processes, we move it to trimming, molding, demolding, all done through robotics. When the panel then comes off, we've essentially got the shape and size that we need. So this is an example here of in-mold coating. So right off the mold, we're able to actually have this color inbuilt into the material. And what this means is that in the event that the vehicle gets scratched, for example, the color is actually part of the actual panel. So you don't have the typical scratches or scuff marks that you get, or paint that gets scratched off. So that means that the operator doesn't actually have to either respray this panel or even replace it. So that really helps the commercial vehicle operators reduce the total cost of ownership. This is an example of a direct comparison between steel and the Arrival composite. And you'll see in the typical industry approach, when we drive the truck over it, you can see that the panel itself is significantly damaged. And this will require replacement. When you look at the Arrival composite, with the added durability that we get, you can see that the form is basically intact. And with a bit of cleaning, you'll be able to use that vehicle as you were before the accident. And what's really interesting about this material is not only is it really durable, it's also extremely light. So this becomes a key benefit to getting added range for the same size vehicle. Here you're seeing a van door, again using the same material, and you'll also see we're able to get Class A finishes with this. So the same material can also be used in the interior, so we get the added benefit of using the same material both on the interior and exterior panels. This is an example of an interior liner that's basically done with the same material as well. Sustainability is a really important part of the Arrival ethos. And with this material, it was actually designed around sustainability in mind. So not only do you replace the panels less, which means you can extend the life of the existing panel, but when you do have to replace the panel, we can actually break them back down into their raw materials. We can use them as filler parts, or we can actually, using a chemical process, recycle them back all the way through the end of life, back to recreating new panels. So we use the same technologies that you see today, not just to make a van, but we also recently announced a bus. And this bus has really been designed all around the user experience, both for the driver, the passenger, but also the operators that use them. In driving down the cost, we've also ensured that these vehicles are also best-in-class vehicles. So for example, the van, compared to its competitive set, it has better payload, and it has better cargo volume for the same size vehicle. The bus has advanced safety features. It has a fully flat floor for passengers to be able to get in and out really easily. And it's a modular design, so we can quickly change the shapes to enable different local variants. Thanks everyone, it's been my pleasure to show you the inside of the Arrival Microfactory and take you through some of the unique things that we're doing in this industry.